Good morning, fellow teachers and students, and good morning, model class. All right, thank you very much. You may sit down. All right, our topic for discussion today is on force and motion, and the subtopic will be Newton's first law of motion. Right? Can anyone tell us the first law of motion? Veronica, can you remember, or if you can remember from our last lesson, what would be the first law of motion?
First law of motion is the law of inertia, which states that every body remains in its state of uniform motion or rest unless it is acted on by an external net force.
Okay, very good explanation. All right, that is the first law of Newton's first law of motion, and that is the law of inertia. That is, any object or body will continue its state of motion or remain at rest until and only when there is an external force acting on it, right, in which it will either stop it. All right, so in this lesson, we'll basically go through and have a look at that, and I will be asking one student to come up and then demonstrate the law of inertia using two plastic water, and what he will do is to insert a stone or an object in there, then he's going to give it a slight move and then see in which direction the stone or the object that was inside the plastic moved. So I want you to watch carefully. To the pilot students, you can see this is one of the experiments that will show the law of inertia. Right? I will ask one moral student to come up and then explain to us. So after he has done that little demonstration, he will have to explain on what he has observed from this little demonstration. Right, Sulaiman? You can use this. All right. I want all of you to, all right, he has to put a, all right, this is a plastic of water. Right, it's filled right to the top. And we have two very small objects which are being inserted in here. One is a marble in there, and one is a red colored object. So we'll place this in the middle, all right, and then what he has to do is to move this container in one direction, and then we'll have to look at the movement of these two objects that is inside the container. All right, he has to tell us where the direction of the movement was and where the object inside this container moved. All right, just give it a small. All right, if you can use the diagram or something like that to explain.
From what I've just done here, I've seen that when I moved the container in, let's say towards the left of myself, the object moved in the opposite direction, moving right, and also vice versa. So what I'm concluding is that the force that I was using was on the object was equal in the opposite. It was, although it was the force that was acting upon this object, using to act upon this object, somehow the force that I was applying to it was changed, and the object moved in the opposite direction of my force.
Okay, that is his explanation from the demonstration and his observation. All right, I have this information on the law of inertia, and after that I will probably give you 5 questions based on that topic. So I want you to start copying this information. All right, if you can summarize this information, the object at rest will continue to remain at rest. All right, if there is any zero resultant force acting on it, let's say for example, if you are pushing a trolley or a pram, after some time you decide to let it go, it will definitely move, but suddenly it will come to a stop. Why? Because there are some external forces acting on it. But if there are no external forces like a resistance force, then probably that pram will keep on going or moving with the same speed or that constant speed. All right, as you can see, it's mentioning two parts, but in all there is only one. It is saying that one object at rest will continue to remain at rest, and the one that is moving will continue with the same velocity or constant velocity unless the external forces act on it. So for this they are one, but we had to really break it down to two parts. All right, let's have a look at the next set of information. But if we have to write that in simple, it will be the force net equals 0, then the velocity will be constant. But otherwise, if there is a little bit of force applied, then sometimes the velocity changes. Okay, all of this information is given by that rule there. Right, that is the first law of motion. Inertia is a tendency of an object to remain at rest, meaning that it is a measure of the reluctance of an object to change its state. Right, from this little experiment, you find that the object was actually at rest inside the plastic. But because there was a movement from the outside, it moved in the opposite direction because it was trying to remain at rest. Right, it's quite similar, especially when you are riding on a bus and then probably sitting on the seat of the bus. And then probably when it is rounding a curve or something like that, probably you'll be moving in the opposite direction. Why? Because you have a tendency to remain in your position, but because the bus was moving, You are now moving in the opposite direction. Right, your activity questions, there are 5 of them. All right, this is the first one. Explain why the following occurred. Number 1, if the BMW suddenly stopped, the upper parts of the passengers lunged forward. Right, especially this is a common example. Probably some of you may have experienced this situation, especially when you are traveling on a car and then probably the driver has to come to a stop suddenly. You find that your upper parts will be moving forward. Finish. All right. Let's have a look at question number 2. Right, this is question number 3. Right, we shall move on to question number 4. You don't need to experiment with it to explain. Right? You obviously know what will happen, especially when you do it. Right? You only have to explain what and why this would happen. Right, just question number 5. And that should be the final question for this topic. Would which is start from 1, 2, 3, 4, 5. Okay. Number 5A, a pair of forces. Okay, for question number 5, a wooden rectangular block is placed. Alright, will it continue to remain at rest if 1, okay, a pair of forces 3 newtons east and 3 newton west, and number 2 will be a single force of 5 newton south 45 degrees west. How many minutes are we into? 54. Okay. We start quickly and then 1, 2, 3. Just stand up and answer your question. Sit down. Number 1, 2. Okay, talks. Number 1. Number 2. Yeah, number 2. Just explain. Number 3. And number 4. Okay, we'll see 5, 1 and 2. All right. Five, 1, 2. Yeah. Did I ask you to do 1, 2, 3, 4? Which number 5? All right, we shall now have a look at those questions and then do corrections on them. Right, for question number 1, Marvin.
When the wave is when the PMV suddenly stops, the upper part of the passenger's body suddenly lunges forward. It's because it's the second part of Newton's first law states if the resultant force acting on a moving object is 0, the object continues its motion with constant velocity. So meaning although the speed of the bus PMV suddenly stops, the momentum is still present, therefore lunging the body forward.
All right, his explanation was that because the PMV stopped, the upper parts of the passengers have to lunge forward. Why this happened? Because the passengers, the upper parts has to keep on moving, all right? And suddenly when it car stop or the PMV stop, the parts, keep on moving because it can link to the inertia, the law of inertia, because any object which will continue to move unless there is a force that is acting on it. So the other parts actually moved, and when a PMV has to stop, they keep on moving. That is why they lunge forward. Right, very good. We will now have a look at the second question. That will be Joseph. Pilot students, you observe carefully and listen while this student will have to explain to us the answer to that. All right, Sulaiman. What do you have in English?
Let's say that this cube here is the car, and the smaller one here is the book. Okay, when the vehicle is moving along the road, the force moving them in this direction, the force moving them are in the same direction. So they are both traveling the same direction, but then there's a change in the force acting upon the vehicle itself. So the vehicle tends to move to 10, and the force, because of the force moving it. But the force on the book does not change, acting on the book. It does not change, so the book continues to move in the same direction as it is, as you can see, where the vehicle is moving, but the force of the book is causing the book to continue moving. So as you can see, the book has moved from this position around the center of the vehicle towards the side, and if there was no doors or stuff like that, the vehicle would continue to still move in that direction and would have fallen out of the vehicle.
All right, good. As you can see from that is a very good explanation using diagram. There is a centripetal force that is always acting towards the center when it is going around the corner. So what happens is that you will find the object that is placed will be falling off the seat, or probably if it is on the top, it will be falling in the opposite direction. All right, good. We'll move on to number. Where's it here?
Takes off, the resultant force, which is moving in the opposite direction of the plane, is great, so it pushes the passengers into their seat. Therefore, they feel their seats pressing their backs.
Okay, good. At this time, the plane is moving and the seats are moving at the plane, and you are just sitting there on a plane. And because it is moving forward, the seats will be pressing against you, and you are in the opposite direction as well. All right, you have the inertia or the tendency to remain in that seat. But because the plane is moving and when it is taking off, you feel the seat that is pressing against your backs. All right, good. We will have a look at these two questions. Number 4, what will happen if you have to kick the same size?
The ball has a lighter mass, so it moves easily when a force is applied to it. However, the stone displays inertia because the force applied to it by your foot is not enough to overcome its reluctance to move.
Okay, good. The stone of the same size will have a larger inertia, right? Meaning that it will remain in its position because you must overcome that inertia. That is why your feet will hurt, especially when you kick the same size of stone. And number 5, All right, who is going to give us the...
The wooden block will remain at rest because there's 3 newtons coming this way, so it doesn't move anymore. Cancels out.
Stated in the law of inertia, an object at rest will move if acted upon. So in this case, 5 newtons in the direction of 45 degrees southwest was applied. So therefore the object moved from its present location to that location. Okay.
All right, good. For the first question, number 5, one would be that the object will never move because there are 2 equal forces on the opposite direction. And for number 2, the object will certainly move because there is only one force in one direction. All right, so that brings us to the end of the lesson. Now, before we go, I will quickly summarize the lesson. Inertia is a tendency of an object to remain in its position unless some kind of forces act on it, then it will move. And when it sometimes moves, it will continue with a constant velocity unless there are other external forces acting on it. So, like the demonstration using this, right, this object has the inertia, a tendency to remain inside, but because you apply a force that is moving that way, right, the object remain at rest, but this time the position has changed and it is down there, right, so you'll be moving in the opposite. All right, so I've given you some examples of what is happening, especially in our daily lives, especially when you are riding on a car. Probably sometimes your upper parts of the body will be lunging forward. What is happened because you have the inertia, or sometimes you are moving with a car and your body's, the upper parts keep on moving, but because it stopped, you keep on moving when it stopped. All right, that is why you lunge forward. All right, so that is the end of the lesson on the first law of motion, or sometimes we call this one as the law of inertia. In our next lesson, we will study the second law of motion. All right. Our key phrase for today will be the first law of motion. Good afternoon, pilot teachers and students, and good afternoon, model class.